Hey, I'm Vince. Welcome to the channel. Today I'm going to give you the longer version of the 5-minute video I did on Thomas Kuhn's the history of scientific revolutions. So I wanted to get a little more in depth on a lot of the issues I see, and I can give more detail or explain it better. This book really shook the academic community when it came out. It's interesting how this book developed. Kuhn was originally asked to write a chapter for the International Encyclopedia of Unified Science. The goal of the encyclopedia was to integrate knowledge from different fields, and Kuhn's chapter was on the history of science. So the goal of the encyclopedia was to show that science was based on logic and how pure science was. The encyclopedia was commissioned by a group of logical positivists. If you don't know what that is, the logical positivist, that's a philosophy that says that only empirical statements can be given any value or have any meaning. And that is, statements could be rationalized and statements that could be rationalized and experimentally verified. So philosophy and science should deal with like things like math. They shouldn't have any feelings attached to them or anything like that is set aside. And so we're trying to turn the natural world into some kind of mathematics. Also, to the logical positivists, science progressed in a very rational order. When scientists do experiments, they are going wherever the science takes them. And Kuhn, not meaning to, really blew that out of the water. So it's kind of funny to think that the people who paid Kuhn for his work to verify what they had already thought ended up just funding a project that mostly contributed to the downfall of that very thought. Kuhn's book is often credited with starting the philosophical revolution of post-positivism. So that's the philosophy that comes after positivism, and it basically says that science is not completely rational and objective. In fact, there's an awful lot of human influence in it. We can also note that logical positivists would say that there does exist some sort of ultimate reality that is separate from humans, and that scientific inquiry gets us closer and closer to that reality. The post-positivists, however, would say that either there is no ultimate reality or that we can't actually get to it. So there's no way to actually get to that knowledge, which some people would call the truth. Now, Kuhn was not a post-positivist, really. He was just writing a history of science. And in an interview, he once said, "I feel like there's two Thomases, the one that everyone keeps attacking and the one who just wrote a book on the history of science." So there was an awful lot of people who found much inspiration in this book, and there was an awful lot of people who absolutely hated it because it went against what they previously thought about science. So what did Kuhn say that was so explosive? What did he realize? What Kuhn said was that when you look at the history of science, you find that it goes through different phases. The first he called normal science. He says that during the period of normal science, there is a prevailing view that governs what scientists do, how they do it, and what they're looking for. That is, they look at the world through a certain lens of what he calls a paradigm. For instance, before the Copernican revolution, the prevailing thought was that the Earth was at the center of the universe. And so all research was done in that understanding. Before Newton, everyone thought that Aristotle was correct in his views of motion, and then everyone thought Newton was correct until Einstein. And then after Einstein, everyone began being an Einsteinian physicist. Before the advent of chemistry, it was believed that there was a material called phlogiston inside a substance that was released to make it burn. And then chemistry is going to come along after that. So Kuhn is not just saying that we believe false things until we discover real things. He says that it's the paradigm, and all research is done inside of that paradigm. So no one even thinks to do research that the Earth is not at the center of the universe, right? Or no one even thinks of doing something to disprove phlogiston or Newton's physics or something like that. Like, everyone operates inside of that paradigm. The primary focus of science in this stage, Kuhn says, is basically puzzle solving. Seeing how things that don't seem to fit the paradigm make them fit. Scientists try to answer questions that come up within that framework. But then there does emerge a crisis. So in the second stage, anomalies start popping up, and the existing paradigm can't explain them. So, for instance, scientists tried very hard to keep the Earth-centered universe, but more and more puzzling movements in the sky just couldn't be explained. Newton's laws worked very, very good on Earth, but as scientists tried to apply these to very large things like planets, or even very small things like atoms, they noticed that the math just didn't work out. Also, when things burn, they lose mass. Great, they must be losing phlogiston. That's terrific. However, metals actually gain mass when they combust. What gives, right? Why does that happen? So a crisis has started, and step 3 is this revolutionary science. This is where new ideas start to emerge, and they're incompatible with the existing paradigm. So, for instance, the Copernican revolution, where Copernicus places the sun at the center of the universe, or the Einsteinian revolution, where he begins to see space as something that changes with mass. Quantum theory, which states that matter has a wave function, or chemistry that explains that metals oxidize and will, turn into something else and gain mass when they burn. And the last phase is a paradigm shift, where the new way of looking at the world is accepted, the old paradigm is gone, and now the new governs a new period of normal science. Why is this so controversial? Well, there's a number of reasons, but they all really center around this notion that science is not as pristine as we might think it is. What I mean by that is that scientists like to think of themselves, and in the modern era, common people like to agree, they think of themselves as being objective and getting rid of all the human influence in an unadulterated search for truth. The point is, we normally think of scientists as going into a laboratory with no preconceived notions, and they just do science, whatever that means. They just start doing experiments or something, and whatever comes up, that's the truth, right? They only deal in hard, cold facts. But what Kuhn is saying is, during a period of normal science, they do operate under preconceived notions, and this governs what they're looking for. Now, this isn't revolutionary. Scientists have always had directed investigations, and that's what a hypothesis is. But Kuhn says they operate inside of a paradigm, and they only do science inside of that paradigm with the understanding that that paradigm is already correct. In fact, in all paradigms, there are problems, so problems don't cause crises. During the period of normal science, the problems appear small, and they're generally swept under the rug. And this really upset the purists, because they want to say, no, we go wherever the science takes us. And so if there's a problem, then we can solve it, or there's going to be a crisis. But there's not always a crisis, right? Now, what stops that process from happening? Well, it could be that the paper that you wrote on such a discrepancy just wasn't accepted, right? Or that they decided not to publish it. Well, who's they? Well, they is the scientific community. The scientific community are like the gatekeepers that decide what can go through and what cannot go through. What do we accept and what do we not accept? And this is where we start seeing more and more human influence. If you start to question that pervasive paradigm, you're ousted. People think you're a quack. You can't get a job at a good university. So a good example to look at would be the theory of evolution. Now, I don't want to be discredited as being outside of the mainstream or a science denier or something like that. The theory of evolution is well supported. It looks like it really governs what the best way of explaining what happened on Earth to living things. It is there's an awful lot of evidence. In fact, I heard one time that there's more evidence to support the theory of evolution than any other scientific theory. However, my point is that is the governing paradigm, and there have been many scientists that question that paradigm, and they're ousted. They can't get, like I said, they can't get jobs. They are disgraced in the science community because they question evolution. Now, here's where I think is really interesting. A lot of times that question is done for religious purposes, right? And then the religious community, well, I say more maybe the evangelical community, has come up with this intelligent design scenario. Now, if you don't know what intelligent design is, that's kind of just saying that there is a creator God, and we can look at creation and we can do some experiments to see how creation must be the only answer. And so here's just a really brief analogy. I know there's probably tons of ways around this, but if you find two things that couldn't exist independent of one another, and they can't arise independent of one another, but A has to be there for B to be there, and B has to be there for A to be there, then you can say, okay, well, those things must have been created at the same time. So that's some of the research that's done in intelligent design. And we pretty well discredit as a pseudoscience. But what's interesting is, with the advent of AI, people are starting to question, hey, I wonder if we're all in like a computer simulation. Did AI develop us? And if that's true, if a computer did develop us, then it's just interesting to me that if you say God did it, then you're a quack. But if you say AI did it, well, now it sounds like it might be real science. And I just say that to say there's so much human influence and human thought into what actually constitutes science and what doesn't. We have other things there that we're actually arguing besides the purity of science and scientific investigation. Okay, funding is also an issue during this period of normal science. People who fund scientific experiments don't give money to people who operate outside of the norm. So it's hard to do any research that doesn't align with the prevailing views, the prevailing paradigm. But also, people who fund scientific research don't just do it out of the goodness of their heart. They generally want a return on their investment. And so funders also guide the pathway of science. I had a doctor one time who used to be a theoretical physicist, but he said it got to be where he was not able to do anything because unless your experiment was either for a drug company or had something to do with quantum physics, you really couldn't get funding to do anything. And it's extremely hard to get a particle accelerator. I mean, there's only a few in the world. So your research has to be what the scientific community wants it to be. I also wanted to mention a video I saw yesterday from one of my favorite science YouTubers, and I'll put the link in the description. And I really thought it went along with this video. This was not a video on Kuhn. She didn't mention him, and not sure if she even knows who he is. But she was giving her story of why she's no longer in the field of physics. And she said two things that I thought were interesting that really bolstered this idea of how science is not just this pure thing that searches for knowledge and truth. And that's first, the institutions are money-making machines. That's what she says, not me, but I probably agree. They get grad students who will get grants, and the university gets a portion of that grant money. So they direct their grad students to do research that is mainstream, and that will bring in more money. So it's not this unadulterated search for truth, it's this unadulterated search for money. And as she said, the research has to be edgy, but not too edgy. And from that, I thought about normal science. You need to not challenge the paradigm. You can say things that are kind of edgy, but you don't want to actually challenge the existing paradigm, or again, like I said, you're labeled a nut. So the goal of the university is not to discover things per se. The goal of the university is to discover profitable things. The second thing she said that I thought was really important was that she was point blank told that the reason she wasn't getting an internship, even though her grades were impeccable, is that she was a woman. Now, this was a number of years ago, and at this time, universities probably get more grants and more prestige for hiring women and minorities. But even at that, we can see that one way or the other, the hiring practices, the publishing practices, the funding practices are not based solely on a quest for truth. So the next phase is crisis. And what's interesting is, like I said, there's always these little things that come up in normal science or in the current existing paradigm, but it's the scientific community that's the gatekeepers, and they get to figure out when this crisis is big enough that we're going to reach outside of the existing paradigm. So that's the crisis. And then we have this revolutionary science where people are doing science experiments, or they're thinking of things, or they're coming up with things other than the existing paradigm. And then we have this paradigm shift. And that's where things really get interesting. What you think is going to happen is everyone's going to rejoice when the crisis is overcome, and everyone's going to say, "Oh, thank you, Copernicus," or "Thank you, Einstein. You have saved science." But that's not what happens, because you're dealing with people. You're dealing with professors and scientists who have made their careers in the old paradigm. They maybe published a bunch of books, and their whole reputation is on the line. So even though there is a successful resolution to the crisis, what happens historically is that the new way is rejected, except by the young students who like new ideas. So many times the younger people don't accept the new paradigm because it's right. They accept it because it's new and it's cool. And then the old guard dies out and the young kids become the new professors. And so the new paradigm takes over. So it doesn't rely on or strictly on this pursuit of knowledge. It doesn't rely on being able to do experiments and saying, hey, this one's better than that one. Really what happens is that the old people who believe the old thing just die off and the new kids come up in. Now that's a very simple view of what he says, but that's at least part of what he says. And so we have to take that into consideration, that it's not just this unadulterated quest for reason, right? Now, here's also something he says that's really cool, and that is when you have these two existing paradigms. So you have this this group of older people who have done all this publishing and everything in their field, and they are Newtonian physicists. And then you have this new paradigm that comes up, the Einsteinian physicists. They can't even talk to each other. They can't argue about this and say which one is right or wrong. They don't have the same vocabulary. So even though they're using the same words, they're always talking past each other. For instance, in that instance, when Newton and Einstein say the word mass, they mean two different things, and so they can't have a conversation. Kuhn calls this incommensurability, and he states that there's not some kind of objective measure which can assess the reliability of the paradigm. And that's another point that got Kuhn in trouble with the scientists, the scientific community, or the logical positivists, because they like to think, and like I said, we like to think too, that there exists this objective reality by which we can measure all things. So, here's the truth, and then we take our theories and put them up against the truth, and we can measure it. But there is no the truth anywhere. There's no huge thing that helps us, or glasses that we can put on that help us see if one is better than the other. There's no measuring post. There's no ruler to measure one from the other, because they're all subjective. So even measuring scientific ideas is a subjective thing. Okay, that is my discussion on Thomas Kuhn's The History of Scientific Revolutions. I would love to hear your comments, or if you think there's something I didn't address. But anyway, I think it's just a really cool book, and all right.